Hi guys, in today's video, I'm going to be discussing absolute value equations, inequalities, and exponents. So let's look at absolute value. So say we have minus 4 and modulus. This modulus sign means that minus 4 becomes 4. So whenever you see these two lines surrounding a negative number, the number becomes positive. So for example, you have minus 3, that just becomes 3. So the negative becomes positive. So now let's look at modulus of x is equal to a. Then x could be equal to a or x could be equal to minus a. So for example, if we do x plus 2 equals 4, x plus 2 could be equal to 4 or x plus 2 could be equal to minus 4. So x could be 2 or x could be minus 6. Now let's look at inequalities of absolute value equation. So say modulus of x is greater than equal to a. This can be written as x is greater than equal to a or x is less than equal to minus a. So you have to remember that whenever you put a negative sign, so whenever you put a negative sign for the a, on the other side, the signs switch. So for example, if you have modulus of x is less than a, x would be less than a or x is greater than minus a. So now let's look at one graph just to explain how they work, absolute value equations. So say we have the line y equals x. Y equals x we know is just the straight line passing through the origin. So this is y equals to x. But now let's look at the graph of y equals modulus of x. We know that when there's modulus, these two lines, there can never be a negative part because the negative becomes positive, right? Remember I explained minus 4 modulus becomes 4. So that means this part is positive, right? Because it's above the y-axis. So you just do this. So you just reflect it. So this V type of shape is y equals modulus of x. Now let's look at graphing linear inequalities. So say we have x is greater than 3 and y is less than equal to minus 3. So we can draw it like this. So once we draw the graph, say 1, 2, 3, minus 1, minus 2, minus 3. Okay, so say this is 3 and this is minus 3. So we know that x is greater than 3. So that means that it's, say I'm just drawing a straight line. So it can be anything within this region, right? Because x is greater than 3. And now for y is less than minus 3. It can be anything less than this, right? So now if they ask what the common region is, isn't this the common region, this part? I'm just going to write it as R. Because this is a place where x is greater than 3 and y is less than minus 3. This is where they both meet. This is where like the common region where both are present. So now let's move on to another question. Linear inequalities graph with two variables. Say we have 2x plus 3y is greater than equal to 6 and we have to graph it. They'll never ask us to graph it. They'll just give us options and we have to take the correct one. So for this, you can just take any value of x. Say x is 0. What is y? Y would be greater than equal to 2. And now let's take x as 3. So that means it would be 6. So y is greater than equal to 0. So now let's draw it. 1, 2, 3, and then 1 and 2. So this is 3, 1, and 2. So we know when x was 2, y is greater than 2, right? So when x is 2, y is greater than this. I'm just going to write an up arrow so that we know that it's above because it's greater than 2. Now when x is 3, y is greater than 0. So just going to draw another arrow because it's greater than. So now between these 2 points, we have to draw a straight line. And this region is the region for this linear inequality with 2 variables. So that's it. That's all we have to know. Now let's look at some exponent laws, some laws of exponents. So a to the power of 0, whenever you have a to the power of 0, that is equal to 1. A to the power of 1 equals a to the power of m into a to the power of n equals a to the power of m plus n. Similarly, a to the power of m divided by a to the power of n equals a to the power of m minus n. Then a to the power of m to the power of n is a to the power of mn. So these are exponents. Then if you have ab to the power of n, you get a to the power of n into b to the power of n. And then if you have a to the power of minus m, you get 1 by a to the power of m. So these are some rules which you just have to memorize for SAT and ACT because they'll usually ask questions. Now we have root of n, a to the power of m. This can be written as a to the power of m by n. And then if x to the power of m by n equals y, then x would be equal to y to the power of n by m. So there'll be a reciprocal of the power. So these are all the laws of exponents which you need to know for SAT and ACT. Now I'm going to be talking about quadratic inequalities. So say you have 2x squared minus 7x minus 4 is greater than 0. If we solve this in the calculator, we get 4 and minus half as our roots. So this can be written as x minus 4 into x plus 1 by 2 or 2x plus 1. You can write it as anything. This is greater than 0. So now we know 4 and minus 1 by 2, right? So we just draw a diagram. Minus 1 by 2 and 4. So now what you do is you take numbers in between. Say any number between minus 1 by 2 and 4. We can take 0 and we'll substitute it in this equation. So you get a negative number which is minus 4. You can just write a minus sign here. Now let's try for a number greater than 4, say 5. You get a positive number. So just write a plus. And for a number less than minus half, say minus 3, you get another positive number. So now we know that this has to be greater than 0, right? Greater than 0 means positive. So between which is it positive? Between which numbers are like in which region is it positive? It is positive when x is greater than 4 and when x is less than minus half, right? Because when it's greater than 4, it's positive. And when it's less than minus half, it is also positive. Okay, that's it for today's video, guys. In today's video, I discussed absolute value equations, inequalities, quadratic inequalities, and some laws of exponents. Thank you.